the projects that we were doing, because I still am a little bit unsure on a couple of those things, which I'm sure we're gonna get in notes. So.
Well, I think where we're at is we're finishing chapter 4 today.
Okay.
And the rest of you correct me if I'm wrong. And I had one person email me saying that we were not doing the chapter 4 project 1. And I don't remember if I said we were canceling that or not. No, it's gone from this one, so we must be not doing that. Yeah. So
I think you did say that, Eric.
I couldn't remember. It looks like from this class I deleted it from the modules, but I didn't delete it in the right spot yet, which is a problem, of course, because it still shows up in your to-do list. So let's write things down. How about that? Here's what I think we should do that will best support your learning in terms of assignments to turn in. And that is, I'm just going to plug this in. I'm going to summarize this for chapter 4. This is for 133 only. All right, so this is just the 133 stuff. So from chapter 4, we did the chapter 4 project 2, which I think we need to finish that today.
Yes, we need to finish that.
I think the last, like, what, 3 questions on it we weren't able to do because of coefficient determination and stuff like that. So we have that. We've got the chapter 4 review, which I don't think we've started at all, but this is the one that we've been saying we want you to do as homework without help, and then ask questions over what you got stuck on. And then there's three worksheets we can choose or choose not to do. And I think we did, I want to say we did the 4.2 worksheet. Yeah, we did the 4.2 worksheet number 4 in class on Wednesday, did we not?
Yes, we did.
And that's the only one we've done. So in terms of what's in Canvas, we have worksheet number 2 and number 2 for these things that we can look at. I don't know that 4.1 is really going to be super useful, because I think it's the more basic stuff of correlation and explanatory variables that we've already done in 4.2 and the chapter 4 project. So I think let's do this. Let's ignore this one for now. Let's look at 4.3 and finish the chapter 4 project. But before we do any of that, do you all have any questions on anything you've been working on?
I think maybe, Eric, what Nicole was asking was, there was also some stuff in there, like I ended up emailing you about 1.2 that's still in Canvas as an assignment that needs to be due. And then I'm not sure if you moved it yet. I haven't. This is the first time I've been online today. It's still crazy over here, but all of the chapter 4 assignments, you had stated we were moving out another week, and we were making them due on Sunday instead of this coming Sunday, instead of yesterday Sunday.
Gotcha. So you all want those to be.
So like chapter 3 right here is showing that it's not due until next week, but it was supposed to be due yesterday. So I had to scroll down and look for it. Is that more of what you were trying to clarify, Nicole? I got a little confused on that too.
No, that was definitely more what I was trying to convey, but you did it way better than what was coming out of my mouth. So thank you.
I've had about 5 cups of coffee and a Red Bull. I'm ready to go.
Well, let's do it. So, okay. So if there's no questions on homework you worked on, let's start on the 4.2 worksheet number 4 that we didn't finish. Or 4.2 number 4. So let's start there. And then I'll get those dates changed. I didn't do anything over the weekend as usual. I'm sorry, I'm working on it, but we'll get there. So I think this is where we're at. Do we recall that I screwed this up? The calculation of the residual? The residual is, oops. Residual is calculated as y minus y hat. And I had that backwards, y hat minus y. When we, or did we not even talk about it in this class? Maybe it was only in the night class. And this is.
What page are you on, Eric?
That is such a great question. It is page 533.
Okay, thank you.
So this is data value minus predicted value. So what on 4.2 number 4, I want to say we did this whole page except for these last 2, maybe these last 3.
Yeah, we left off, we finished question G, but do we do the next page, page 534 too?
Yes, let's do
Okay.
both. So we need to pick up here. Okay, let's do a quick reminder of how we did G, because we need G's answer for whatever letter comes after G. So we did this, the equation here was y hat equals negative 0.05x plus 5.3. And we noted that the contraceptive prevalence rate was a Y value. So we're using this as a Y hat to predict an X value. Let me just double check that real quick. Nope. This is prevalence factor is an X value because it's on the X axis, and fertility rate is a Y value because it's on the Y axis. So down here, we're saying that X is equal to 63. I know we already did this, but I think it's worth rehashing. So X is equal to 63. So we're going to plug that value in for X to calculate a predicted birth rate for Kenya based on this contraceptive prevalence rate or percentage. So this is the more straightforward one because you just multiply it out. Oops. So I got what we're supposed to give 2 decimal places. Well, come on now. Okay, so that answer was wrong. I get 2.15. Is that what y'all had?
Yes, but for some reason on F, I have X equals 76%.
That is probably correct. Sorry, this is for G. I just wrote in that space because I knew I needed.
Oh, okay.
You're good. I think we noted that this was a Y value of 1.5 and then we solved. And I think I showed you how to do it with Desmos graphically, or you could do it algebraically. Does that sound like something I would have done?
Yeah, that's
Okay.
exactly what you did.
That's okay, good. It's hard to remember between the 3 classes what I did with what. I tend to do the same thing and tell the same stories, but you never know. Okay, so that leads us to this residual. Now, the residual, I believe, is in your reference sheet. So I'm going to go to page 263 real quick to show you that. So here it is, residual. It's the observed Y value minus the predicted Y value, we call Y hat, or the actual data value from the data set. We hand that to you, and then you calculate the trend line. Notice trend line is another word for the linear or the least squares regression model, or the linear model, or the linear equation, or whatever we're calling this mess. So we can also call that the trend line. So this is the formula that we're using to do that calculation. I have it written here. You just decide whether you want to clean it up for your own personal reference sheet, or if you know what's going on based on what's handed to you there. Now, can you all calculate it? How about I give you 3 minutes to do H? Set a timer for 3 minutes. You got that, Taylor? 533, letter H. We're finishing the 4.2 worksheet number 4. And we're just completing H. Anyone got the answer? That was 3 minutes. 1.35. Does everyone agree? So here's our y hat. Here is our y. Based on our formula, that means we should have 3.5 minus 2.15. Misty, you crushed it. That is 1.35. Now, before we say I, yeah, feels good, doesn't it? By the way, notice you have to have those two values. And whenever we do this problem, we're always going to ask it this way. We're going to have you predict something using the model. Something's wrong with the computer. So that this here was the prediction in G. We hand you a explanatory variable value, and then you use the model to predict a response variable value, the y hat. And then we're like, well, actually, surprise, it was this number. It was actually 3.5. Calculate. Now, if you think about how this is done, our predicted value was smaller than the actual value. This means we underestimated. It's an underestimate. Now notice that means a positive residual means an underestimate. A negative residual means an overestimate. I know you did this in the notes. If we were to do this in the notes here, we predicted for 63, which I think is like roughly here-ish. We predicted the value right here. That's on the line, right? And Kenya's actual value was 3.5, which looks like it's right here. So Kenya's actual value is above the trend line. That's why we have, I think that's the rationale here for our underestimate. It's a positive value from the trend line up. Is that making sense, or am I just talking craziness? Anyone know the answer to I? So what does our residual imply? Triple I, let's see. Kenyan women are having more births than expected due to a positive residual. Excellent. Yep. Okay. Questions on that? All right. So I would love for you all to do number 2 from start to finish with no help. I'm going to give you 10 minutes. As a quick reminder, you need to get into StatCrunch. And you need to type the stuff in. I will give you this hint. Recall that the first column is X, the second column is Y. And so to make life easier on yourself, why not label the columns in StatCrunch X and Y, and then type in your stuff. So I will pause here. I'm going to give you 10 minutes. Does that sound good, y'all, or are you feeling like that's a waste of time and we need to talk about it a little bit? 10 minutes it is. Set a timer for 10 minutes. I'll also open where you're supposed to go to get your stuff. I'll just do that. After you open the regression, you get this thing. And then all you're doing is selecting the X variable and the Y variable based on the first column and the second column, and then compute. And you'll get this big mess of stuff. Is that helpful, Laura? Okay, good. I might have typos, so this might be wrong. If you have different numbers than me, one of us is wrong. Hooray! Okay, then we must be right.
I am not coming up with the stuff that you're getting in your simple linear regression results. And I'm trying to figure out why why I'm not getting the same thing. Is there something, you went to stats, regression, simple linear, and that's all you did?
What's different? Is it these numbers?
Yeah, so I must have numbers off somewhere.
Yeah, double check this. Let me double check mine just in case.
Oh, yep, I know exactly why I do. Okay, never
Nice.
mind. I
Good.
did the wrong number set somehow.
Oh, okay. Reagan, do we round up the decimals or write all of them? Let's see. So here it says give 3 decimal places for the least squares regression.
Like for the Y-intercept, do we round it to 3 or just do the thing?
It doesn't say, does it? Do a couple.
Yeah. Okay.
Since their percentages 1 or 2 decimals was plenty. Okay, that's 10 minutes. Y'all need more time? How about 5 more minutes? Set a timer for 5 minutes. Okay, how are we doing? Are we ready to talk about this?
I am ready.
All right, so what'd you get for number 1? Number 1A. Find the least squares regression equation. And you said 0.4. Okay, so Emily, I love your answer. It's a great answer for the R squared value, which is the coefficient of determination, 0.4211. What 4A is asking for is the least squares regression model, which is a great word for the linear equation. The thing you should focus on, I think the most common word in all these is the model or linear model. I think model shows up in almost every definition we use. No worries. Don't feel bad. That's what we're learning here. There it is, LaShawn. You forgot one tiny thing. And that's the X value. So the answer is this mess right here. Now, Misty, I'm wondering where you got the 176.995. Oh, you got it from right here. Ignore all this stuff below parameter estimates. This is all things that are, although intercept and slope might be sort of helpful, and standard error we kind of talk about, but this is called the Anova table, and it's pretty complicated. I would have to look back at my notes from a couple of my grad classes to really explain what's going on there. So for now, note what we're looking for is this equation right here. Oops, this thing. And the 3 decimal places are the 3 for the 2 parameters, which is the Y-intercept minus, talk to me, Reagan. That.
So this equation is y hat, but it just says y's in the thing in StatCrunch.
Check this out. Look what it says now. It says var2 and var1, right? So the reason I did that is because whatever you type here is what's going to be listed in there. Now, I don't know if StatCrunch will allow us to type y hat. You should always know that when you find a least squares regression model, the y we write as y hat because it's a predictor value. That's how we keep it separate from an actual data value. If you forget it, don't worry. StatCrunch is never going to put it in there unless you figure out how to write y hat in StatCrunch, which is probably possible. Yeah, Misty, that would explain why the rest was crazy. Okay, so what's the slope then of this regression equation? Now that we've gotten it written down correctly, or do you all need a moment to, now that we've done this? Well, how about we just identify the slope? So we have time to do everything else. Do you all remember which number is the slope? Oh, one other note here. Once we've written down the model, rounded to the correct decimal places, kind of ignore the other stuff and stick with the decimal places for answers from the model that we've just written down. I don't know if that makes sense. One, two. Oh, my answer is wrong, by the way. Rat. Were you all bothered by that? Okay, y'all, what's the slope? And if you have no clue, tell me that too.
I thought the equation was the slope.
Okay. No worries. Awesome. All right. So let me quick go to page 263. This is your reference sheet. Note that I'm so glad we're having this discussion and you are saying that. The slope is in StatCrunch, but the equation is this. So this is the equation. And the A number in the equation is the slope. And the B number is the Y coordinate of the Y-intercept. Which I think can blow some people's minds, because you're like, don't we just want numbers as answers in math classes? And sometimes we like that. In this case, this is the equation, and the slope is the number multiplied times x, just the number. How are we feeling about that?
So is
Misty,
that,
go ahead.
sorry, is that a subtraction or a negative, or it follows it wherever it goes?
Yes, to all your questions. That's the fun thing with negative numbers. Negative numbers are negative numbers, and they're also subtraction, and they're also multiplication. So it's a confusing mess. If you look at how the equation was written like this in your notes, and StatCrunch writes it like this. So if we wanted to write this equation in the same format as our notes, we would have to switch the order of these two terms, and we do it as negative 0.208x. Oh boy, now I'm out of space. Oops. Plus 27.201. So, like, it's a really bad answer that I gave you. The negative goes with the particular number. We could talk about the algebra of why that's true, but I don't know if that would be terribly helpful. Okay, cool. Now, who has the sentence explanation? And if you don't have it, let me refer you back to your reference sheets, that I'm hoping as you're doing these worksheets, you're using this, because here is the thing you're going to write. You're just going to replace the appropriate parts with the context from our problem, which we didn't actually go through yet, did we? So does anyone have that sentence, or do you need a second to try to write it?
I got it.
Go.
On average, if the percent of literate citizens increases by 1%, percent of the undernourished is expected to decrease by approximately 20.8%.
Okay, good. One small fix.
Yep.
And that is, these percentages in the data set are percentages.
Oh.
So this 0.208 is also a percent.
Got it.
Otherwise, perfect. Crushed it.
Wonderful.
Let me write that down for the rest of you. On average, if I'm just going to say percent literate increases, what you said is better than what I said, but I don't want to write all that, by 1%, percent undernourished is expected to, now, why did we say decrease? Does everyone know? Sorry, I didn't notice.
Because it's a negative.
Nailed it. So whenever we never write the sign of the number in the problem. We don't write the plus sign, we use the word increase. We don't write the minus sign, we use the word decrease, and then we just write the number down. So keep track of that. I think we talked about whether or not I would actually mark you wrong. If you wrote the negative and decrease. How do we feel? How many of you think you could do that on your own? And if your answer is you can't, then we need you to practice until you can, because you get the chance to do it on your own at the midterm. Hint, hint.
Yeah, not yet for me.
That's okay. We're going to get there. Yeah, that's okay. It's good to know where you're at, to know what you need to practice. So we'll do another one of these. We'll check the project one, because I think the project has it as well. The things that you are changing, let me highlight that again. You are typing in this piece. You are typing in this unit. You're writing this context. You're deciding whether it should be increase or decrease based on that sign. And then you're writing in the slope and its units. Everything else, that's the shell of the sentence. On average, if you figure it out, increases by 1 blank. So we're always talking about the X increasing by 1, and then we just have to put the units on it. So let me make that a little clearer. We just have to say that part. And then we're talking about what's the Y variable. By the way, notice the answers to these two things came from right here, although I got lazy in how I wrote it.
So that's always 1 increase or decrease by 1.
For the X, we always look at X increasing by 1. So this is fixed. We never change this piece right here. And the reason is because that's how we read a graph. We read a graph left to right. So we're just saying, if we do this by 1 unit, what happens to the Y value? It either goes up or down. We don't read graphs from top to bottom or from bottom to top. Same way as like when you read a book, we read from left to right, and then you turn the page left to right. Of course, there are other languages where you read right to left and whatever, but that's how we do these graphs. That's the reason this is a fixed increase by 1, and then you choose, do you decrease or increase by the slope amount based on the number from the equation. Y'all want me to make up a problem real quick? No,
Yeah, I would like that.
yes, you would. Okay, let's do it.
Yeah, because I'm lost still.
So this is going to be a weird one. All right, so just be ready. Here's my equation. Y hat equals, I'll do it in the same order that StatCrunch gives it to you. $36 plus, let's do it like this. Plus 10 cents times X. I'm going to do a graph to give you what X and Y represent. So X is pieces. Of course, I'm going to do Legos. How could I do anything else? How do you spell pieces? Is it P-E? Is it P-I-E-C-E-S? Pieces? That seems right. And then this is price. All right. So this is cost of a set based on pieces of a Lego set. Where the X variable is pieces, the Y variable is price. Here's what I want you to do. Identify the slope and interpret it in the context of this situation. 5 minutes.
Is that a decimal in front of the 10?
Yes, this is why you're supposed to put zeros. Good call. Thank you.
You're welcome.
Eric, I bet some pieces cost $10 per piece.
Oh yeah, 100%. There's one piece that's like $40, and it's just this little tiny piece that only came in one set, that it came in that particular color. It's a Krusty the Clown Lego set. It's crazy.
Do you have it?
Mm-mm.
I did not know that you were a Lego nerd. You got to show us something cool.
This is what I'm building while you all are working. And I'm not cool. I'm just like building it from instructions. Here, you want to see something cool? That's Legos. So is that. Everyone else ready? Okay, y'all want to type your sentence in chat? Or actually type in your slope or say your slope. What is the slope?
10 cents or 10x.
Nailed it. Although, if we keep the units, remember slope is change in y divided by change in x. So it's really a 10-cent increase per one piece. So you're not wrong in saying, hey, the slope is 0.10, but you should think in terms of 0 over one piece or 10 cents over one piece. Cool. All right. How about you all type your sentences in? Or say them, whichever you rather do.
Can I just say it?
Yeah, say it. Go.
I got on average, if the amount of pieces increased by 1, then the price will increase by 10 cents.
That's it. That's it. How y'all feeling about that?
So when we write these sentences, is it always like you put the y for +1 or the x, like
if it goes up by one, whatever the unit is, it's always the X?
Yes.
Okay.
It's on it. And so that's where, when you look at this sentence structure on page 263, it is always on average if whatever the X value is increases by 1, whatever the units are, whatever the Y value is expected to increase or decrease by about whatever the slope intercept is. Talk to me, Taylor.
I think what we're trying to do on our notes on page 118, I think, is that the same thing that we're doing now?
100%. Yep. Yep. Good. We're working on this piece, making sure we can write that sentence interpretation. Really good. Yeah. And the notes where you practice that sentence was right here. Explain the meaning of the slope in the context of the situation. Here you did fertility rate versus life expectancy. Showing that the more children are born, the shorter the nation's life expectancy is. Go ahead.
So just to let you guys know, those notes are all filled out for you. And I sent you a thing saying that I had to do a recording because my internet here at the cabin was bad. So I went into a McDonald's and I did a recording for you. So if you didn't get the notes for the remainder of chapter 4, you can go back to it's posted underneath Thursday, but it says Friday Zoom session, chapter 4 notes. So I have all of chapter 4 notes filled out for you. So if you didn't get those, you can go back and get all of those chapter 4 notes. So tomorrow I'm going to be starting with, hopefully you guys are going to feel more comfortable enough, but you can bring questions. I was going to start with section 5.1. So if you haven't had a chance to watch that recording where I went over all of, pretty much tried to get you caught up, part of 4.2 and all of 4.3.
Do you all want me to write down the interpretation here of this slope, or are we happy with that? So what I want you to do now is go to your project, and we'll do the piece in the project. Oh, not wrong class. We'll do triple wrong class. We'll do the slope interpretation in the project. So this is the chapter 4 project. Come back here. Come back here. Chapter 4 project 2. And first, let's make sure we're all on the same page on this. Has everyone got this like mostly started? Because I think we did. We gathered the data. We did the stuff in StatCrunch. Where you're all at on that project?
I still have number 7 blank and then 11 to the end blank.
Perfect. That's what we want. Okay. Quick catch up. Let's make sure we all have, well, first everyone get in there. While you're doing that, I'm going to pull up the simple linear regression for this. And just copy it into there so we have it to work with. Easy killer there. Ooh, easy. Oh, and then I guess we should, maybe I'm going crazy. Do we need to go back and finish the other worksheet so that we're not so like all over the place? I kind of wanted to go here so we could practice slope again, but we didn't finish. Maybe we should just finish that worksheet altogether.
I would like to finish the slope thing because that's where I'm struggling personally, is to continue with the slope and then go back to the other one.
Okay, I like that. So let's skip down. What we need is question 8. You need to answer question 8, because after that, you're going to interpret the value of the slope. So we first need to know what is the least squares regression line? Notice this time we called it a line. In the worksheet, we called it the least squares regression model. So first, are we all on the same page? This is project 2. Awesome, Taylor. It looks like you're spitting out the equation. Were we told to round it to anything? Here's the equation. I'm going to copy it from the output and dump it in here. And then I'm going to change this to Y and this to X, just like I think that's what you did, Taylor. Yeah, you did. And just because I want to be super duper cool, no, I'm not going to put in Y hat. I'll just draw it in there. You can type it, but there we go. Okay. Oh, it says 3 decimals. Never mind. So let's do our 3 decimals. I can just get rid of those. Oops. And then here's the 3rd decimal place. It's a 1 after that, so I can just get rid of all that mess. There we go. Okay. So first off, you need to carefully recognize the context here. We had people measure their forearm length and then measure their height, how tall they were. So X represents the length of someone's forearm, Y represents their height. Now, you all, let's do 5 minutes so I can keep my mouth shut. You all interpret the slope of this equation. Identify it and interpret it. Set a timer for 5 minutes.
We didn't do 7 yet either.
Nice, y'all. Okay. You're right. Is everyone happy with those sentences dumped in the chat? I'm just going to grab one and type it in here.
I missed centimeters on mine. I didn't mark that. On my increase by 1, I should have had centimeters in there.
Yep. Technically, it should be there. That's right. Yep. You want yes, we need the units for the X values and the units for the Y values. It just so happens in this context, they were both the same. Okay, we'll do this on the worksheet too. Does everyone know what the coefficient of determination is? Don't tell me the number from our problem, but tell me the symbol for it. This is number 6. We know, I think we answered it, but what's the symbol for coefficient determination?
Is it R?
Close.
R squared?
You got it. Nice. Right? It's one or the other, right?
Yep.
Remember, you do actually have to write that one down, because in the reference sheet, we just write R and R squared. And then in StatCrunch, in the output, it states that R is the correlation coefficient. So in your provided reference sheet, it doesn't say anywhere what's what, but StatCrunch gives it to you there. So you just need to make sure you know which one is which. So it is R squared. This is the number for it. And then did you see there where I had The interpretation. This is 3 decimal places, so we don't need any of that. There we go. How do we interpret it? It's right here. It's blank percent of the total variation in Y is explained by the least squares regression line. I like to replace this with just the word model because it's a lot less to write. And it's correct language to call it the model is correct, although it's not as precise, but it's okay. So first, in our problem, what does Y represent? And I forget who it was.
The height.
Yeah, there you go. Okay, so Y represents someone's height. That's not how you spell it. That's the beauty of word. There's how you spell it, height. So our interpretation is just that, now watch this, 25.9% of the variation in height is explained by the model. That's it. Notice I took the decimal version of R squared and converted it to a percent. And you're always going to do that. That's a common place where I take off a half point because people will say 0.59%. You always have to multiply this by 100 to convert it to a percent. Other common mistakes I see on interpreting the coefficient of determination, people want to write out a slope interpretation. I've seen some crazy things written here, and it's mostly because those students didn't have a chance to practice, is really what it comes down to. So I'm not afraid for that for any of you here. How do you feel about that between 6 and 7?
So the coefficient of determination is squared and coefficient is just R.
Nailed it.
Okay, got it. I thought at first you were saying coefficient, whatever. I was just mixed up. I was like, oh Lord.
They're so close together, right? Correlation coefficient is R. Coefficient of determination is R squared. Like, come on. Could we have been nice? No, we don't like being nice in the math world. They share that word coefficient. Okay, so let's jump back to 534 and let's now practice with the Y-intercept. All right, hopefully you haven't gotten whiplash. So for C, we're doing C. Let me give you like 5 minutes. You may not need that much. Oh wait, we already did it. What's your answers for C? Oh, Cindy, I just got your text. It was my tutoring hours. Oh, here we go. You are 50% correct, Reagan, 50%. The other half is you need the X coordinate of the Y-intercept. And that piece is always the same. And this is the most common mistake I see students make on identifying the Y-intercept. They just write the number. So make sure you give me 0, the number from the equation. We need both. Nailed it. That's it. Yep. That's what we want. And the reason you want that is because this 0 is the number for, in our context, percent literate. And this 27.21 is the predicted value for percent undernourished. Nice, Misty, you got it. So I'm going to ask you to tell me the interpretation. Meaning, let me quick jump to 263. I want you to type in this sentence. It's not what we need to do for the question, but I want to see that you can actually do this, because in my opinion, if you can interpret it, you can explain why it doesn't make sense. If you can't interpret it, you might not be able to explain why it doesn't make sense. So I think the two go hand in hand. So type out or tell it to me.
I was calling because I want to change my
The interpretation.
practice for my girls on Wednesday.
I got you muted, Laura, no worries. So give me that interpretation, y'all, and then we'll talk about why it doesn't make sense.
Like 4 times.
Okay, anyone else stuck?
I'm always stuck on this stuff.
Okay, good. Well, let me write it out. So just as a reminder, hopefully you have your sheet out. I am just copying and pasting this with the replacement of the pieces that need to be replaced. The X, the units, the Y, the B, and the units. Okay, so that's what I'm about to do. Okay, when X, well, what is X? When the percent literate of a nation or country, I don't know what's the difference, is 0%. Okay, that part is fixed. This 0 is always the X coordinate of the Y-intercept. The percentage part, we had to note that from the units. And the literate part, we had to note that from the context. Okay, so when the percent literate is 0%, now we talk about Y. Percent undernourished is expected to be approximately, and about is a cheaper word, 27.201%. How do you feel about that?
Okay, so question.
Talk to me.
So we're looking at the problem. It's telling us that 94% of Mexico's population was illiterate in 2017. So we don't even worry about the 94. It's just the fact of the percent of literate. And then to get the Y-intercept we had, or to interpret the Y-intercept, is X is going to be 0 if we copy the thing down. So that's where we get the 0% because we're taking the units. And then the next part is going to be the other part of the graph, which in this case is percent undernourished, which is going to stand for Y, and then it's just the Y-intercept.
That's it.
Okay,
Now,
I think I actually have it then.
Yay! The one thing is, don't worry about this yet. This is its own separate problem, this 94% stuff. For C, we're just taking this number and saying, hey, when X is 0, Y is this. That's what our equation predicts. Here's what this ordered pair means in context. If we have a nation with 0% literacy rate, we expect there to be a 27.201% undernourishment rate. So what the question really says is, why does this not make sense? And go ahead, Nicole.
I just wrote it in the wrong spot. So I don't even know why I was looking at D, but I was trying to make out what C was, and I just totally put it in the wrong spot. So either way, though, I think I get it now.
Okay, good. So then is there, so when you're asked, explain why it doesn't make sense, the correct answer is not to write out the interpretation. That doesn't explain to me why you think it doesn't make sense. What you're looking at is either, is this value kind of ridiculous, or is this value kind of ridiculous? So let me start with the less kind of ridiculous value. That's the number for undernourished. Is it possible that a nation could have 27%, or a country to have 27% of its population hungry, not being fed enough? Is that a reasonable number, I guess, is the question we want to ask. I don't know, Taylor, maybe not. We're going to write it. We're going to, I don't know. We're going to use this to help us explain why it doesn't make any sense. It's okay if you leave it on there. So what do y'all think? And these are kind of unfair questions, like we talked a lot about earlier, where you have to know context. Does everyone understand what we mean by undernourished?
They're not fed enough.
Got
They
it.
don't eat enough. They don't have enough nourishment.
That's it. So this is hunger. It exists in America. It exists everywhere. I think to the most extreme, we've got people dying from undernourishment, right? And that happens all over the place. Go ahead, Nicole, what you got?
I was thinking the droughts over in those other countries where they're talking about people are dying by the thousands.
Yep.
So as far as that number, could it theoretically, depending on the part of the world, could be a potential reality?
The point is, it's possible, right? We could have even higher percentages of a country undernourished. I bet if we looked at what it was in America, we'd be shocked. We're the wealthiest nation in the world, and yet we don't really take care of our people. The number of, like there should be no one hungry in our country. Jeff Bezos should donate all his money to the hungry or something. I don't know. That's just my opinion. But so the point here is, this is possible, right? Now, that doesn't explain why the Y-intercept doesn't make sense. How about this 0% literate? Do we think that is possible? Now, do we all know what we mean by literate?
They can read.
You got it. Do you think it's possible you could have a country where no one in the country can read?
That's a very sad government then.
Yeah, I don't think that can exist, right? Like it exists in maybe hunter and gatherer societies that still do exist in some places. Have y'all seen that island in India where like they kill you if you come on the island, basically? That it's kind of, there's some Christian kid tried to go in there and be a missionary, and they like filled him with arrows before he could even get on the sand.
Yes, that was a crazy story.
Yeah, and the people told him, don't go there. They're going to kill you. They don't want outsiders. And the Indian government kind of like protects them and lets them live their lives. They probably don't read. I would guess. And then there's places in like Brazil, whatever. I'm talking long about, there are groups of people that aren't literate, but in terms of a country that has a government, this is not possible, right? How else are you going to have courtrooms, and how else do you record things? So this is why it doesn't make sense. So our answer for C is 0% literate is not possible. You can't have a country without literacy, as far as we know, right? some form of literacy. So that's anytime you're asked to explain why it doesn't make sense, that's what you're doing. You're looking at the X value. Does 0 make sense in the context? And you're looking at the Y value. Does it make sense in the context? Sometimes Y values are negative. And so if this was a negative undernourished, that's not a possible value. So you would state that, oh, you can't have negative of these units. How are we doing on this? Does this seem okay? How about you jump back to the worksheet and do this exact same question. Write out the Y-intercept and explain why it doesn't make sense. And if you need to, write out the interpretation like I just did here and use that to explain why it doesn't make sense. If you don't need to, that's great. But if this is helpful, that's also good too. On the midterm and the final, I might ask you to interpret the Y-intercept, or I might ask you to explain why it doesn't make sense. Be careful. Interpreting and explaining why it doesn't make sense are two different things. So try it out for this one. Let me do a 5-minute timer so I can keep quiet. Set a timer for 5 minutes. Nailed it, Laura. You want to tell that to everyone else? Oh, flip those actually. So what's helpful in these? I'll speed things up. X-axis, X value is explanatory variable. In our context, that's the arm length. Y value is the height. Apparently I can't spell height. So when we're doing the particular Y-intercept of our model, it says that when the arm length is 0, we can expect the height to be Oh, I just noticed a mistake up here, by the way, y'all. Let's go back to our slope problem. We expect the height to be this. And what Laura pointed out is that you can't have an arm length of 0, which is kind of true and kind of not true. Let's say most people do not have an arm length of 0. That's highly uncommon. I had a student that was born without one forearm. You know, it happens. Or someone, veterans that have can have an injury where you lose an arm. So it's possible that you could lose an arm, right? But in terms of our problem that we're working with, we're using someone's forearm to predict their height. And so if you don't have a forearm, you can't predict their height using your forearm. You'd have to use something else. So in that context, that's what we mean here, that it wouldn't make sense because you can't, a 0 arm length isn't a useful tool for predicting the height in our model. Go back to number 9. I missed this. We used the Y-intercept instead of the slope in the interpretation of the slope. So for number 9, on average, if forearm length increases by 1 centimeter, a person's height is expected to increase by approximately 1.252 centimeters is the number that should go there. If it was increasing by 135 centimeters, that would be crazy, ridiculously tall, I think, for every 1 centimeter forearm. How are we feeling on that? You all feeling okay? Notice how we had to use the interpretation to explain why it doesn't make sense. Like, you have to understand the interpretation of the Y-intercept in order to explain why that thing doesn't make any sense. Okay, let's go back. We're in the 30-minute mark before the end of class here. Let's go back to the worksheet and let's see, how did you do for D, E, and F? What did you all get for D? Or what did you do for D? Or were you totally stuck?
I was totally stuck.
Totally stuck.
Okay, let's read it and get you unstuck. So we got that 94% of Mexico's population was literate in 2017. Okay, Regan, how did you know that 94 was an X value?
Because it says the percent literate, and if you look at the table up above, that's the X value.
Perfect. That's the first thing we need to note. Second question. Oh, look, we did it to you. What would the model predict? Well, what's the model? It's the least squares regression model. So we took off a bunch of the words for that, right? So that means we're going to use y hat equals 27.201 minus 0.208. And then we're going to plug in for X, our number for X, and make a prediction. Those of you that said you were stuck, does that make sense? Is that helpful?
It's going to take me like 6 hours to complete this midterm exam.
That's okay. Maybe. Maybe. By the time you're practiced up to it, I think you might get a little faster. But I also don't mind if you want to take 6 hours to do it. I'm not a fan of speed math. If we were watching Mean Girls, then maybe we'd talk about speed math, because that's how she won that calculus thing and got to go to the dance and became crowned the queen of whatever she was crowned of. How does everyone feel about 7.6? Dog, what are you chewing? Sorry. When the dog chews on Legos, they get put down. How does everyone feel about 7.649? Yay. Anyone lost on that?
Would the
Talk.
so would the units be undernourished then?
Yes, it's 7.649% undernourished. Very good, because that is a Y hat value. So now that we have D, we can do E. Anyone remember the residual formula?
The whole bottom line of 263 next to residual.
Nailed it. Yes. Good. Good. I love that you have that in your head. Yeah, good. So do it if you haven't already. The units on this residual, by the way, are the same units as the Y value. And I know I'm speeding up a little bit. It's for the sake of time. So, I mean, I shouldn't have written the answer so soon. I should have let you all try it. Talk to me, Regan. Or Reagan. Am I saying your name wrong?
No, it's fine. You can say I really don't care. But
tell me how to say it right, please.
I usually say people say Reagan, but it's fine.
Reagan. Okay, Reagan, go.
So 3.6 since the Y hat was negative 7.649, wouldn't it be like minus a negative? So it's basically plus a positive.
Did I do that wrong?
Maybe.
Oops. I got a positive 7.649 for
Oh,
D.
how did I do it wrong?
That's what I got too. I'm using a regular calculator and
Okay,
I just
maybe
do
my
the multiplication
calculator.
first.
Okay, my calculator probably. My bad.
No, you're good. You're good. It's you might have done this. You might have done 0.208 times 94 minus 27.201. Nope, you didn't do that. Oh, wait, I said 64. So you might have just typed it in that way and got a negative, and that's.
Yeah, so what did I do?
So you made the 27 negative instead of the.
Okay, my bad. Yeah, that is what I did. Okay.
So that'll change it. Yeah. Yeah. Otherwise you would have been right. But you can pause and say, if you'd had a negative prediction here, what is a negative 7.6% undernourished? Right? Does that mean 7% of the population is overnourished? And what does overnourished mean? That's a thing you could think about.
So Eric, wouldn't this be an overestimate?
Yes. So, which is weird because the variable itself is percent undernourished, and we've overestimated the amount of undernourished.
Oh, sorry. I thought that
good.
said underestimated. It says undernourished. Sorry.
Yeah,
I'm on a phone, so it's really little.
Yes. Well, and it's a great highlight of like we're using some of the same language in the variable as we're using in our interpretation of the residual. So just how complex and complicated, that's the same thing, the language of stats can be. It's a mess. Okay, so what did you all say for F then? Yeah, great question, Taylor. I think, were you the one that emailed me about that? I don't think we've looked at 4.1 and 4.3 yet at all. Let's finish this. What'd y'all get for F? Okay, actually, let's think through what this means. So Mexico had a high literacy rate, or had this literacy rate that predicted they would have a 7% undernourished, which is bad, right? We don't want our population undernourished. That means they're hungry, food insecurity, whatever. Isn't there a number out there that like 1 in 6 children in America experiences food insecurity, which seems crazy high? That's 16% of children in America, if that's the right number. Okay, so they actually had a lower undernourishment thing. That's good, right? We want our undernourishment to be 0% if possible. So they're at 3.6%. Our model predicted 7.6. We predicted a much higher number. So number 3 says they're doing a bad job. Well, they're not doing a bad job because they're doing better than we would expect, right? We expect 7% to be hungry, but only 3% is hungry. So they're doing a good job. And that's because it's actually I. They're doing a good job because the residual is negative, which means an overestimate. And you have to be careful with this because overestimates and underestimates are not inherently good or bad. It just depends on what is the context. If we were talking about death rates, an overestimate is what we would want because that would mean less people are dying. But if we were talking about, I don't know, what's something where an overestimate would be negative? It just don't assign positive or negative things to an over or underestimate. You have to look at the context first. I don't know if that makes sense. How are we doing? Have I distorted this too much, or have I cleared up some of the craziness? Are we feeling better?
Cleared up some of the craziness. It's just a lot to remember.
Yes, practice makes permanent. So just practice perfectly and you'll be perfect. Okay, let's skip back to the project then to sort of answer your question, Taylor. We need to finish it. So this says, what value did you give as your forearm length in centimeters? We didn't answer that question. So make up a number.
Quick question.
Please.
Question. Earlier, you guys changed something around we did, and you said it wasn't that, and then we changed back to the worksheet. What was it that you changed? I think it was in number 9.
Oh, yes. In number 9, the number here was the Y-intercept. I missed it. We had 135.306 in our interpretation of the slope for number 9, but it should have been 1.252 because that is the slope.
Okay, thank you.
You're welcome. So just for helpfulness, boy, I don't have a good concept of centimeters. Let's all use our estimate for our forearm length as 100 centimeters. Does that seem reasonable, or is that a lot? That's a meter. A meter long forearm, does that seem right? Does this look like a meter? Whatever, who cares? So this says, use the regression equation to find the predicted height based on your forearm length. Note, this question 12 is the exact same question we did in G, back on the number 2 worksheet, and it's the exact same question as D. We're taking a value, plugging it into the model to create a prediction. So do that, get your prediction, then calculate the residual in number 13, like we just did. 14, I just gave you the answer, it's the residual. And there's another prediction here too. All right, so you get to do it twice. So I'm going to give you, let's do 5 minutes and see how well you do on 12, 13, and 15. So the timer for 5 minutes. Are we stuck? You need this. Yeah, that's totally cool. If you have a different number here, I mean, you can make up whatever number you want. Doesn't matter to me. If you use this number, I got 260 and 506. 9.806. Did I do mine wrong? How'd you get that, Nicole?
It looks like I subtracted instead of added. Never mind.
Gotcha. Okay. We would have put on the units, this would be centimeters tall. Does everyone know what to do in 13 now that we have this answer? Okay. Nailed it. Okay, so we're all gonna have different answers here. Let's say I'm 5'10". Hey Siri, how many centimeters is 5 feet 10 inches? According to the internet, that's my actual height. I just predicted my height would be this. So my residual is, oops, negative 82.706. So probably that 100 centimeters was a little long. How are we doing? Is everyone tracking? Are you all,
So if we did the numbers that we had been using, the 100 centimeters and stuff, so would that be a negative 126.20 or 0.20?
what number
Oh, I
did you
used the wrong
use
number.
here?
Never mind. I used 135.306 minus the 260.506.
Yeah, negative
So-
125.2.
Okay.
So if that 135 centimeters is your actual height, like your forearm is probably not 100 centimeters long. It's probably a bit shorter. Just like for me, my forearm is probably a bit shorter. Although if we look at the R value for this thing, it's not particularly good predictor anyways, right? Only 25% of the variation is explained by this model. So another way to kind of think about this is it's roughly 25% accurate. So it's not very good. Awesome. Do you see the common threads going on here? You find a model. You interpret its parameters, the slope and the y-intercept, using your sentence structures. You take a data value, plug it into the model to predict. So you take an explanatory data value, plug it into the model to predict a response variable, in other words, a y hat. You calculate how far off that prediction is, in other words, the residual, and then you mention something about that residual. Does that make sense, y'all? What's going on here? Like if we were to boil chapter 4 down to its essence, that's it. Find a model.
I think we should set it on fire.
Well, yeah, it just burns the alcohol off. So then it's just the sugar's left, right? I don't know. Sugar burns too, doesn't it? 15 is the same question as 12. The exact same question. Because here it says, use the regression equation to predict the height of someone with a 5-inch long forearm. In other words, they're going to 12.7 centimeters. So we just plug in that value for X. How did we know it was X? Because it says forearm length. That was the X variable. Let's see, what do I get? 135.306 plus 1.252 times 12.7 gets us a 151. 0.206. We're supposed to explain why this is not reasonable in the context of the situation.
Is it centimeters on the end of the 151.206?
Thank you. Yes. Oh, why is it not reasonable? Because 5-inch, what's a 5-inch forearm? That's like a baby's forearm, isn't it? I think 12.7 centimeter long forearm is ridiculously short. Is an infant's for arm length and you don't measure how tall infants are. You measure an infant's length, not height. Right? Y'all know that? Because if you don't have kids, you might not know that. They don't like try to stand up your baby against the wall and then measure them. They like stretch them out on the little piece of paper and they do marks on it. And that's how they measure how long your baby is, to track your baby's growth until they can actually stand on their own 2 feet. And it's wildly inaccurate. Go ahead, Taylor.
So for assignments that were due this week, it was 3.4 worksheet 2. Like, did we go like get answers for any of those or like go over them?
Stop asking, Taylor. We didn't. No, we haven't even started these because I keep talking too much. Sorry.
You did, Eric, you did 3.4 worksheet number 2 last week.
Oh, I'm so sorry, Taylor. You asked about
That's
3.4?
Chapter 3. Yeah.
And I'm sorry, Taylor, if that teasing didn't come across very good. I got to not tease. That was really bad of me. I hope that was okay.
You go over that one.
Okay, so 3.4 worksheet. Which one? Worksheet number
2.
2. I'm pretty sure we did that in one of the videos. Am I right, y'all, or did we not? I'm pretty sure we did do that whole worksheet. Let me double check.
I'm pretty sure.
Yes, we did. We did all of this. And we did all of this. And we did, so we did this one on Wednesday. I remember we talked about it on Wednesday. And then this one this stuff we did on Monday. I'm fairly certain. And for the Wednesdays, we did this like at the end. Is there a particular one of these questions that you're totally lost on?
I realized I have it. I'm sorry.
You're good. You're totally good. So what we have not done at all, we have not looked at 4.1. And I think we can just skip 4.1.
Eric, I did 4.1 worksheet number 1. So I did cover 4.1. So I think we're good definitely with 4.1. But I did not do a 4.3.
Okay, so what we haven't done, this is the one that's on our thing to do. If you look at it, it's all the same questions we just did, except for this last stuff. What I would like to do is skip that one. And I want you to do chapter 4 review from start to finish. And when we get, so it's these 3 pages. It is very similar to what we just did. Notice here's a, what is the slope? Tell me what it means. Here's a Y-intercept. Explain why it doesn't make sense. Here's a prediction value. Here's a calculate a residual. Here's a, what's this? Tell me what this is. Interpret this. Here's another graph of a residual plot. Here's another of like a data set, find stuff, and write some relationships. So I think this is a really good summary of everything you need to know from chapter 4. And I think this will be really good practice for you to sit down and see, can you do this without me or Cindy helping you? And then I need to change the due date. In class on Wednesday, I would be happy to answer any questions you ask about it. Like, hey, I tried this and I have no idea if I'm right or wrong. Go ahead, Taylor. I saw you on mute. What's up?
So which one did you say that we are not doing? Is it the 4.1 worksheet 2?
So yes, we're just gonna remove that. And I know you do not need to turn this one in at all. Nor I'm also saying, let's get rid of the 4.3 worksheet for now. If when we look at the chapter 4 review together, this one's done, completed. If it feels like you still need more practice, we'll bring the 4.3 worksheet back and work on it. So for now, I want to see you finish the chapter 4 project 2, which we've done all the answers together here. And then I want you to see this on your own without help, to just see where you're at, kind of a gauge of like, because I know you've been saying you need tons of practice. So let's see if you can, if the practice is going anywhere. If you're totally stuck on it and have no clue what's going on, let's talk, right? We'll work on it together. So you'll do those 3 things for chapter 4 for 133. Is that clear, everyone? I know I'm like terrible if you're super organized kind of person. I haven't been this semester. It's like my worst semester ever for that. Any questions on what the work you need to do between now and Wednesday? You may have noticed that earlier today, I put in grades for a bunch of the worksheets. So I finally put some grades in. What I did is the ones we've been doing in class, I just said, if you turned it in, I'm going to give you 100%. I'm going to grade for correctness the chapter reviews for sure. That's on my agenda. That's been on there since the first day of class.
I have a question about the quiz that we just had to do last week. I think it was over like 3.3, like quiz 2.
Mm-hmm.
I don't know if my email had gotten through to you guys, but after like question 10, it was like asking for like I don't even remember, but it was asking for something, and it was like for the data above, and I was confused on what data we were talking about.
So Taylor, I sent you an email back about that it was for question 7, where you had to run like a linear regression, and then that for chapters, or that question, then you used for the remaining questions. So you use that. So I thought I sent you an email back, or it was either a reminder, something I sent back to you and said, just use your data that you did for number 7. You can still get back in there and do that. So even though it's past the due date, so what you're going to do is use your data that you did when you ran your regression from number 7.
Because I think I tried, well, the first time I did it, like my computer died, and then like I just had to use the second attempt, and like I have one more left, but I was just like super confused on what.
No, just use your data from number 7. When you actually run the regression, use your data from there. It is kind of confusing because you're going back up like further into the questions. So yeah, you're like at number 10 and it says data above, but it is from question number 7.
Laura, is that what you're referring to too?
It's just,
or are you referring to the fact that I kept going back between worksheets and projects today?
No, I'm okay on that. I kept getting lost on what data I was supposed to use as well. So that was my same question.
Gotcha.
Yeah, so you guys, if you need another attempt, let me know and I can give you another attempt. Otherwise, you should get in there. But we need to let Eric go because he has his other class. So yes, get in there and do it. If you need another attempt, yes, I will do an assignment sheet. I was waiting to kind of talk with Eric to see what his plan was. So Eric, I'm going to plan on lecturing 5.1 tomorrow and maybe do my one. I have 5.1 worksheet number 1. So the only thing that you would need to do is a 5.1 worksheet, or if you were going to do answer questions, obviously on the review on Wednesday. And then I don't know what's up with chapter 5 projects, but you probably wouldn't want to do that yet because we would only have got through one section.
I usually skip those projects anyways because I don't find them particularly helpful.
Yeah.
So we'll do for sure. What we're going to do on Wednesday is the 5.1 worksheet, whatever's in here. I always forget which one it is. Worksheet number 3. And 5.2 worksheet number 3 will probably have to move. but we'll see.
All right, sounds good. All right, so you guys let me know if you need more assignments or if you need more attempts for that quiz. But yes, just use your data from number 7. All right, Eric, you have a great day.
Yes, you all have a great day, and we'll see you on Wednesday.
I'll see you tonight. Bye.